So welcome everybody to the second in our series of training. Rob has been generous enough to go through it. I will record it and it'll be up on our site for anybody to view it at any later time and for anybody who missed it. So Rob, today's topic was, what was it? Was it racks? What was today's topic?
Rack power distribution.
Okay. So rack power PDUs, and Rob put together a presentation. So Rob, I'm going to just turn it over to you and let you run with it.
All right, cool. Thanks, Sam. Again, I put this together and I tried real hard to keep from getting real technical with it, although it's a little bit difficult when you're just kind of talking about power. So I'll apologize on the front side if some of what I say may kind of fly over your heads. Just glean take some nuggets away from this. It's just good to hear the nomenclature sometimes, and if we get into anything regarding math, you don't really need to know a lot about that, other than that we have a lot of resources here to kind of help, but it helps kind of set the stage for when we're talking about rack power. So when we talked last week about the Data Center 101, and we went through the various kind of high-level components of the data center, and then we talked about assessments, which I really appreciate the level of activity that's picking up around that. I showed this slide, right? It was the inside of our line card and said we can provide all of this stuff. And so today, you know, the box we're looking at is really kind of what we're going to focus on today. So we're going to, again, high level, and then I'll get a little bit more granular as this evolves. But really, if you recall, if you were on last week, we talked about that acronym PDUs and that it means two different things kind of in our world, in the infrastructure world. And one of them was the big box, kind of circuit breaker box that sits oftentimes in the data center, of which the whips, the actual cords with outlets on them, fan out to the different cabinets and different equipment. Today we're going to be talking about the other PDU, which is the power strip that we often correlate to being inside a rack or a cabinet. There are lots of different shapes and sizes and configurations and voltages and amperages, and we're going to go through kind of almost item by item here and hopefully familiarize yourself with the breadth of our offering, what's available, and why it's important to know this stuff, and at the end on how to qualify an opportunity. And I can tell you that when the support team is asked to quote rack power for opportunities that come in where the end user doesn't have a SKU he needs to get repeat business on, or a competitive product that we're trying to cross to something else, there's almost always pieces of missing information. So hopefully that we have to go back then, and you know, some people, like if it's on the channel side, resellers are like, man, you mean I have to go back to my customer and ask him this stuff again? Well, yeah, because we're not necessarily clairvoyant, but power strips for cabinets, there are some really important things that we need to know in order to help you. So hopefully this presentation will go through all of that, and like Sam said, it's going to be made available to you. So let's start with the form factor, and this is the physical size. This is what these things look like. There are two primary flavors that we talk about, and then a couple that are not so common that we're going to talk about on the next slide. So we've got a horizontal and a vertical. Horizontal PDUs are, can you guys just mute me? We will open up for questions along the line. Thank you. So the horizontal form factor, you can see two of them across the bottom. Those are sometimes referred to as rack mount. Rack mount devices get mounted in cabinets or racks, and the manufacturers typically ship these things with the little ears, the right angle brackets that the user screws into the sides of these things and allows you to rack mount into a cabinet. So these two guys down at the bottom, the one on the left is a 1U, 1.75 inch high profile, and the one on the right is a 2U profile. They do come in varieties of depths and outlet configurations and where the input cords come in from, etc. But this is the form factor is rack mount or horizontal. The more common thing that we get involved in, it probably dominates the amount of rack power that we sell and propose, are these vertical or 0U, and you can just see two arbitrary examples that I put here on the right. You know, one is a single row of outlets, and another one is a wider package. It's got, you know, 2 rows of outlets in it. Again, both of them have different input cord locations, and that's really important, and oftentimes it's overlooked, right? So examples of that would be if there's a slab floor data center and the power is being routed to the cabinets overhead through a busway or some other means, you don't want to have the input cord of the PDU coming out the bottom of the PDU, you know, and then it's going to have to get routed up another 7 feet just before it leaves the cabinet. You'd want the PDU coming out the top, or I've seen people actually install these things upside down. Some of the manufacturers, if there's a display on the PDU, the display actually has a little sensor in it that'll automatically rotate the display if you turn it upside down. So you're covered there. It's just the writing, the actual, you know, the screen printed information on the PDU would be upside down. But some manufacturers now are savvy enough to offer input cord locations, whether it's a top entry or a bottom entry. On the rack mount, again, some of the cords come out the front, like the 2 units that you see here, where the input cord locations are. Some come out the back, and we just need to be cognizant of what the customer's requirement is on the front side. The last two don't run into a whole lot, although about in the last, not this year, in 2015, we sold almost $1 million of this Vertiv MPX product. But the last two are more kind of modular. This top unit that you see in what I refer to as a front-end PDU, this is usually a very high voltage, extremely high amperage unit of which you can plug smaller power strips into these receptacles that you see here and actually use them as kind of like satellites. I know HP had a lot of configurations for their cabinets around this, so they'd have the ability to you know, add smaller form factor vertical strips and put them in different locations in the cabinet. We don't get too much involved in that. We don't get too many requests for that. The other one is this that you see at the bottom. This is a MPX product from our partners at Vertiv. This is a very modular power strip. There's some good points and some not so good points about this. You install a full length. This is a vertical power strip. I just have it shown on its side here. So if you rotated this thing kind of 90 degrees clockwise so that this input section down here would be at the bottom, right? The input cord would be plugged in here. This is kind of network and sensor connectivity. We'll get into that a little later. But these are all separate outlet modules that plug into a common backplane, and these can be field swappable, hot swappable, and upgradable to have different types of outlets or different counts of outlets, with the thought that as a company evolves and scales, they can it's tough to get someone to swap a power strip in a cabinet. It's tough to get someone to do a refresh with gear that's already up and running. But this thing lets you do hot swappable without removing the main power components of the power strip. So it's kind of cool in that regard. It is very expensive and it is physically large. The thing that I kind of don't like about it is its overall depth. You can see the size of the breakers in these modules, and then the units, pretty deep. So it does cover up some things in the back of a cabinet and makes access a little bit more difficult. But like I said, we had a couple customers and sold about $1 million worth of this stuff, and so there are people out there that really like it. Some high-level definitions here. I'm an electrical engineering guy, so I had to throw this in and took a few brain cells out of the back of my head to come up with this. But so, how's electricity work and what's the lingo we use? The charge is the electron. That's what's going to move through the wire. That's what electricity is. It's not something you can see. You can certainly feel it, but it's not something you can see or really get a sense of kind of physically what it is, but that is what's moving on the wire. The voltage, we represent it as volts, and that's the potential. That's how much of this we want to move. And the current is how fast we're going to move this charge, this voltage charge across a wire. So we talk in the context of amps when we're referring to current. We talk in the context of volts when we're referring to voltage. I'd say 99.9% of the opportunities we get involved in supporting are AC power strips versus DC, but we do have a vendor in Server Technology that offers rack-based DC power. That is a separate subject for a different time, but I wanted to let you know that there is a vendor that we carry, and DC is very specialized in some applications, more on the telecom side than in the kind of the traditional data center. But there are some real inherent benefits to DC power, but it's a completely different architecture, and today's not the day to discuss it. So AC stands for alternating current. That's what we're familiar with. That's the wall outlets in our house. DC stands for direct current, and those are kind of batteries as an example of what DC is. In North America, the AC voltages we typically talk about and using come in three different kind of flavors. Single phase is what we're most usually refer to and use in our homes and our offices. That's the little smiley face kind of plug you see on the wall, and those are usually lower voltage at 110 to 120 volts. You don't hear two-phase or split-phase, that phrase being used, but now we've got two wires that can generate voltages that are higher in the 200 to 250 volt range, and then the higher powered solutions, both in what's coming into a data center and oftentimes into higher density racks. What's run to them is something called three-phase, and there's two flavors of three-phase that are out there. I'll get into a little bit about that. Again, that would be a highly technical discussion, and if anyone wants to learn more about, how the difference between delta and Y, technically I'd be happy to go through it. I'll touch on it just a little bit, but three-phase is for really high capacity applications. So we deal with power strips that support this entire realm here in North America. From an amperage standpoint, we talk about the context of, small, lower amperage, 15 and 20 amp units. That's real low to maybe mid-density racks. A lot of real old legacy stuff may run on that. sweet spot based on everybody that says the average density of a rack is still from kind of 3 to 8 kilowatts. You're right in that 30 amp range. So we quote a lot of and sell a lot of power strips that have a 30 amp rating. And then when you move into the higher density applications, there are some physically larger. When you move into the higher amperage, the wires get bigger, the cabling gets bigger, the breakers get larger, everything kind of gets bigger except the actual outlets that you plug gear into. So we play in all of these levels, again, here in North America. When we're talking about power can be, is always represented as watts, right? So, or kilowatts, and a kilowatt is equal to 1,000 watts, right? Kilo is a metric for 1,000. So power is a instantaneous metric, right? You can talk about a watt, but the consumption of power, how it's used over time, is represented as a kilowatt hour. That's what we get our electric bills and what we pay against. That's what your meter records outside your house. So a 1 kilowatt device that runs for an hour is 1 kilowatt hour of energy. Again, difference between single phase and three phase, at least here in North America, AC voltages now come as a sine wave, right? We sell a lot of UPSs, right? Schneider, APC, Vertiv, even, the active power stuff, a little bit of Eaton, the Mitsubishi. Everyone's UPS is designed to make that sine wave look like that top, nice and clean. In North America, we run a frequency called 60 hertz, so that sine wave is repeated like that 60 times per second. Deviations from that really affect the performance of the gear and their lifespan. And again, most of the time a UPS is doing power conditioning to make these sine waves look as pure as that you see here on the screen. Three phase is 3 of those sine waves going on at the same time, and they're out of phase from one another by about 120 degrees. And three phase is, again, where most of the really large power opportunities require three-phase power to have them run. A little bit more on that, right? It's the most efficient way to produce and distribute power and electricity, whether it's on the wires, whether it's coming into the building, whether it's coming out of a UPS. Inside a data center, you would have transformers in your power stream that kind of can break down the voltages and lower them, as well as to split up the phases and create different voltages for different applications and allow people to have power panels, the little breaker boxes that can distribute voltages that the transformers have stepped down. So three-phase power is constant over time. Single phase, again, it can be a little bit disruptive. The last bullet point, again, this is information only. You can deliver a lot more power over a common wire with three-phase than you can with a single-phase application. There are some inherent be carefuls with three-phase, and the most important be careful is this thing called load balancing. So you'll see on power strips where you have meters, and we'll talk about the types of meters and what they do in a second. When you have three phases of power, an X, a Y, and a Z phase, you can combine 2 of those to get the desired electricity into different outlets in the power strip. So you combine the X and the Y, you combine the Y and the Z, you combine the X and the Z. And what's real important is this thing called load balancing, and you want them to be as closely balanced, the same amount of current being pulled by the equipment, the same amount of power consumption on each of these kind of 3 sets of phases that you see here, because if you don't, you'll get problems with the amount of power it's going to be consumed to power a particular piece of gear, or you're going to throw some power back towards your power conditioning equipment, and you'll kind of wreak havoc back at your larger PDUs and some of the transformers if you have an imbalance. So in the early days of 3-phase power in the data center, it wasn't highly recommended, especially when you had IT guys just starting to plug stuff in from the bottom to the top, and they didn't pay attention to the actual load balancing. Today, the power strip manufacturers make it a little bit easier on you. They'll color code the outlets, or they'll group the outlets and stagger them, so that even if you do the bottom to the top, plugging stuff in from the bottom to the top, it aids in the load balancing kind of without you having to make a conscious decision. But make no mistake about it, the load balancing is critically important when 3-phase power is being used at the rack level. Lots of plug and outlet configurations. This is a blurry chart. I can send this chart to you. Just kind of grab it and try to expand it. We're going to hone in on some specific, more common things. But 2 things to glean here is that plugs are the male ends, right? The things you stick into an outlet. The receptacles or the outlets are the opposite end. And whether you're doing a straight blade or a twist lock or a NEMA or an IEC, and we're going to get into that in a little bit, you can't really make a mistake and plug one size into the other. If you look at all these different shapes, they're all different. So you can't take a 30 amp, 125 volt twist lock plug and plug it into a 30 amp, 120 volt receptacle or something like that. It doesn't work. So you can't really make a mistake into plugging something into a wrong receptacle, because it just doesn't line up. But what we most commonly see in our industry, we'll talk about NEMA first. And NEMA is an acronym that stands for the National Electrical Manufacturers Association. This is a kind of a governing body that sets standards for electrical components here in North America. Everything you see here is what's more commonly used on the input cord, the end you plug into something on this power strip, how the power strip itself gets its input current in voltage. And these are all what's referred to as twist lock connectors. So these things go into an outlet and you kind of click them 15 degrees kind of clockwise to your right, and the plug locks into the outlet, so it can't inadvertently be dislodged without someone physically, it's like locking a faucet and then undoing a faucet. So it's pretty safe. And the nomenclature that NEMA uses, it does make sense if you understand it. If you look, there's a little hyphen in between all of these kind of plug types in red. The L means it's a locking plug. That's what the L means. And the 5 to the left of the hyphen, that all refers to kind of the lower voltages, the 120, 110 volt stuff. A 6, like you see down here, that refers to a higher voltage. So this is a locking 250 volt plug, and the stuff to the right of the hyphen, that is the amperage rating, and the P means that it's a plug instead of a receptacle. So up top here, you have a locking low voltage 20 amp plug. This would plug into a receptacle that's an L5-20R. Similarly, down below, this is a high voltage 20 amp twist lock plug. This would plug into a receptacle that's called an L6-20R. So once you kind of understand that, it makes a little bit of sense. Two types of three-phase, again, one's called Delta, one's called Y. The difference is what's called a neutral line that the Y provides. So when you see a Delta, you have your three phases, your X, Y, Z, and a ground. It's 3 wires plus the ground. And when you have the Y configuration, it's 4 wires. It's the 3 phases, a neutral, and a ground. And again, these kind of drawings here that show the shape and the curvature and the sizes, you can see that you couldn't take the L520P and plug it into an L630R. They wouldn't line up and match, so you can't really make a mistake there. The other types of plugs and receptacles, and this is more so now on the receptacles for sure on the power strip itself, but then we get into the actual cord sets that come with the gear and the perhaps the type of input plug on the power strip itself. So this is an international standard called IEC, and so this is the International Electrotechnical Commission, and that's the governing body for setting standards internationally. And this is a little bit more simple to understand. They have odd numbers and even numbers, and they pair up a odd and an even number for the plug and its matching receptacle. So the odd numbers refer to the receptacles. Most common in our industry are things called C13 and C19. The inlets or the plugs, those are referred to as C14 and C20, and then they're grouped in numerical sequence, right? So you have a C19 outlet and a C20 plug, and a C13 outlet and a C14 plug. This guy down here in the bottom right, this is what's referred to as this IEC 6309. It varies in size and diameter, but this is how very high-powered configurations are enabled, right? So this is these things look like the end of a fire hose. I mean, they're probably in the hundreds of dollars, sometimes up to $700 just for the actual plug you see here itself. It could be 3 or 4 inches in diameter, have a watertight seal, and huge connectors. Because when you're running high amperage, you're talking large gauge wire sizes. The diameter of the cord may be over 1 inch in diameter, just the cord itself. So these are referred to as pin and sleeve. Sometimes they're called Russell Stoll. That's a brand name of the connector. But again, that's also an IEC spec, and it's used in very high power applications. So when we're looking at a power strip, when you're looking at the outlets of a power strip, you can see NEMA outlets, right? These are the ones you're more familiar with in your home. This is a 5, so you can see there's no L in front of the 5. That means there's no locking. It's a straight blade, right? It's straight up and down. For low voltage applications, you know, these are rated at 15 to 20 amps. Typically, it's a continuous rating of about 16 and a max of 20 for these things. And it's usually legacy single-corded devices or small appliances that don't require a lot of power. The more common outlets or receptacles that you see in the power strip that we use are the IECs, right? The C13s and C19s we just talked about, the odd numbers. You can see there what they look like here. The C13s down below, and these are typically associated with the higher voltages. So everything in excess of 200 volts is going to plug into this, and that's basically everything your customer uses. Every server, every current revision of a piece of data center hardware has what's called an auto switching power supply. So it figures out what kind of voltage you're feeding it and makes an internal adjustment. And I will tell you that power supplies in servers and other types of hardware run more efficiently at a higher voltage than they do at a lower voltage. All right, so the C13s, they're for a 12 amp to 15 amp max in North America. They rate that down a little lower internationally. And then the C19 outlets, which look like these upside down kind of, an eyes and a mouth, those are for the higher amperage ratings at the higher voltages. We sell a lot of power strips today that have combinations of C13 and C19 outlets in the same strip, kind of like you see here. This particular strip would have to be a three-phase Y, and the Y configuration actually allows you to get the lower voltage in the same power strip along with higher voltages. So now that we've talked about kind of the form factors and the types of outlets, the types of plugs and receptacles, we'll talk about the functional attributes, because now there's a whole lot of, we talked about the actual distribution of the power and some of the terminology, but now it's like the added capabilities that these strips can provide, from basic all the way up to kind of outlet level monitoring and switching and everywhere in between. So we're going to go through each of these as examples so that you understand what this terminology means. And these are general terms referred to by most all of the PDU manufacturers, certainly the ones that we carry in our portfolio, and I'll show them at the end. A basic power strip, a basic PDU is really a glorified outlet strip. That's all it is. It's providing power. It's a little bit more industrial case, and it's physically sized to mount into a cabinet. But at the end of the day, it's got an input cord, it's got outlets. There's no other functionality other than it's providing a number of outlets for your customer to use. The other thing I wanted to add is kind of back to this is as we move up this food chain, the price for these, you pay for each of these features in the pricing. So as we move up, the price goes up as well. A metered PDU, this would be your basic best practice in the data center if you're talking to a customer about power distribution. If you see a data center and they got dumb strips in there, they're either not as concerned about the gear, maybe throwaway gear for them. I mean, perhaps a hyperscale data center that instead of trying to do a repair on a server, they just replace the whole thing. Like my son got a dent in the door of his new car, and they replaced the whole door. They didn't even try to suck the dent out or anything like that. And companies like Facebook and Google, et cetera, those types, throw their gear away if something goes on and just replace it with something new. And they may treat power the same way. But a meter on a power strip is an important best practice in most data center applications. And the meter provides the aggregate current draw. That's the total amount of power current being consumed by this power strip. So that tells you if your strip is rated for a particular amperage, right? You got a 20 amp plug feeding this thing. The last thing you want to do is plug a bunch of gear in there that exceeds 20 amps. A common problem is that people look at outlets that aren't used and figure that there's available power there. If there's an open outlet, I can plug something into it. Not necessarily the case, and unless you have a meter that's telling you that, you don't know, and the last thing you want to happen is someone to trip a breaker upstream and take down an entire power strip or an entire cabinet because they thought there was power out in a receptacle and it was already maxed out from everything else that was plugged in. So there's kind of pictures here of a horizontal and a vertical. What's cool about this vertical one, going back to the three-phase, remember I said that the manufacturers are doing some things today to help prevent that imbalance or the load, to improve the load balancing. So this particular manufacturer uses 3 different colors of the outlets. There's a white, there's a gray, and a black. So that represents the blending of those 3 phases, and it repeats. And this has a combination of C13s and C19s in the strip, and they go from white to gray to black, white to gray to black. So you can help along the way with the load balancing by following that kind of process. You can also see there's 3 meters in here on a 3-phase power strip. So again, moving up the food chain, and everything we're talking about now builds upon what the previous was. So basic didn't have a meter. A meter is basic. You know, you add a meter to a basic power strip, and now it's a metered product. Now you take a metered product and you add a network connection to it. Now you have network monitoring, alerting, and the ability to add accessories through connections to the power strip. Anything that's got a network connection that you can monitor and remotely view is referred to as a Smart PDU, okay? So anybody that wants to do remote power management or remote power monitoring is going to want at least one of these smart power strips. So you can see, in addition to the meter that's on these power strips down here, here's a blow up of another manufacturer's, an exploded view, and you can see the network connections on the power strips. So some of them, like this guy here, this is a Geist meter, they have 2 network connections. So they have a backup network connection, so for added redundancy. The things that look like RJ11 jacks, the phone jacks that we have in our homes, that's where an accessory like a temperature humidity sensor would plug into a power strip. So a lot of manufacturers' smart power strips have the ability for you to plug in an accessory, and the most common accessories are the temperature and humidities. What comes along for the ride when you have a smart power strip are these things called master and kind of linking units, because there's a real cost in a data center to assign and maintain an IP address, right? You need an available port on your switch. And when you've got a large fleet of power strips that you want to have some intelligence in, it's an unknown cost when people are talking about pricing of a power strip, but there's a back-end cost to actually provision the IP address and make it available to a power strip. So what our manufacturing partners do is they allow you to kind of position these things with a kind of a master and a linking unit. So one IP address can control 2 to 4 power strips typically across the different manufacturers, and there's a physical cable that connects the master unit to a linking unit. The other main thing people use smart power strips for is now you've got some software and firmware integration in the power strip itself where you can set thresholds. So if I have a power strip that's rated at 30 amps, the best practice in the industry is something called derating. You never want to load it up to 30 amps, and 80% is kind of where we talk about drawing the line. So 80% of 30 would be 24 amps. So let's just say you want to set a threshold at 24 amps for this 30 amp power strip, and I want an alert to be sent out from the power strip to me when that threshold is exceeded. That way, if you look at the example I gave earlier where, you've got available outlets but not necessarily available power, that way when the guy plugs in the last piece of gear that gets you up to 24 amps, now you can have the alert sent out and management can take the necessary steps to stop people from connecting more devices into that power strip. Moving up from the smart power strips, now we add what's called outlet level control, and the power strips are called switched PDUs now. So now you not only have the ability, I put the same pictures up there, now you have the ability to turn outlets on and off remotely. Now you can power cycle or reboot something, a device, if it's an unmanned, if it's a satellite site, if it's a branch location. Oftentimes there may be network gear in there, and if a Cisco switch or router goes offline, in order for it to be properly administered, it may have to get power cycled, and instead of rolling a tech or rolling a truck out there, someone can remotely connect into these via IP and power cycle the specific outlet that switch is plugged into. So it's a huge benefit for a lot of companies who have remote sites that they need to manage and have responsibility for, and uptime is a requirement, et cetera, et cetera. It really helps to reduce downtime in any type of administration that needs to happen. Again, they're a lot more expensive than smart power strips, but there's definitely a niche requirement for a bunch of customers to use this. It also enables clients that buy some advanced software to manage entire fleets of these network-attached power strips, so that you can do some kind of neat things from a management perspective. Now you don't have to worry about if someone plugs a piece of gear into an outlet that they think has available power and the strip's already maxed out. You get that alert that 24 amp threshold has been exceeded and you have a switched power strip. Now you can shut off all the unused outlets. Now you just render them useless. It's like putting the child protective plastic thing in the wall at home. You can't access it. You can't use it. You plug something in, it's just not going to run. So that's another benefit of the switched PDU. The last now, and this is kind of these particular units have been on the market, I don't know, maybe 5 years or so. Now we're talking about outlet level monitoring and control. So you remember when we started talking about the meter that's in a metered strip, the meter that's in a smart strip, the meter that's in a switched strip, all reflect the aggregate, the entire power being consumed by the unit. When you get into outlet level monitoring and control, now you can look at the specific power being consumed on an outlet by outlet basis. And you can correlate that into turning that outlet on and off as well. So our manufacturing partners in the industry has kind of honed in on two primary uses for this and why customers would want to pay the extra money to actually have that really acute outlet level monitoring and control. One of them is something called chargebacks, right? So if you've got a data center in a large corporation, an enterprise data center, you got an accounting department, an engineering department, design and development, a marketing department, et cetera. You're hosting all their respective servers and hardware in your data center, and the CFO wants to charge each of those departments against their budgets for the amount of power they consume on a monthly basis. You could do that by measuring the accounting guy's consumption for his servers. the marketing persons for their servers, et cetera, by using this outlet level monitoring and control. The other thing is for perhaps in co-location, where you may have several different clients or types of departments within the same company plugged into the same cabinet, and then you can branch out and associate just particular gear to a particular client, and give that customer the control over just his particular gear. So this is the most granular means of doing power strip monitoring and control at the outlet level. The technology to make this all happen usually adds physical size to the form factor of the power strips. So when you see a power strip that has this outlet level monitoring and control in it, now you've got individual relays associated with each outlet. You've got current transducers that can measure the power for each outlet. So all of those components translate into a larger physical package, so that some of these are larger and take up more space in a cabinet. And again, that's something we can help our customer from a heads-up standpoint. Most all of our manufacturing partners can provide specification data on the form factor, the dimensional things. So there are some be carefuls out there when you're talking about. And some cabinets just can't accept this either. Legacy old cabinets, or where the rails are really close to the sides of the cabinets, this may not be a good fit. You may need to talk to them about a better means to install these power strips and their gear in. The last kind of, and this doesn't necessarily add that, in that hierarchy of the food chain, but these are two more kind of unique PDU kind of topologies out there. One's called an automated transfer switch, an ATS. I threw up a picture of an APC unit there. So this adds a level of input power redundancy for gear that only has one cord, right? So we didn't really talk about that too much, but most all servers and other types of hardware that people are putting, equipment that people are putting in racks, have dual power supplies there. So for failover redundancy purposes, it's an A feed, it's a B feed. If one goes down, the other can consume the entire load. The server doesn't crash, et cetera, et cetera. We talked about, 5 nines of availability last week. So if you've got a legacy piece of equipment, some people have modems or smaller power consuming gear that only has one cord. You're going to plug it into one of these ATSs, and there's 2 power feeds coming into the ATS. So if one of the inputs goes down, the other one will kick over instantaneously for the most part, so that single corded device stays up and running. The other thing you might see is really a dual input PDU, and it's really a single form factor. It's a single package, a single unit that's really 2 power strips in one. They have 2 individual inputs. They have each input has a series of receptacles that's associated with it. It's just in one physical package, and those come in both rack mount and vertical form factors. So how do we qualify these things? Like when we're in front of customers and we're talking to them about rack-based power and they're wanting to talk to you about it, what are the things that we're going to ask them to hone in on just the right solution for them? And what are the things that you're going to want to send in to us if you're going to ask us for options from different manufacturers? Again, I said, this is the kind of largest gap we have between feedback from the field coming into us to enable us to give you a quotation and provide an option. So Oftentimes, some pain points are discussed, but, you know, obviously we want to know what types of cabinets these are going into. Some of these power strips are very long, so the last thing you want to do, you know, a 42U cabinet has 73 inches of available height inside. The last thing you want to do is take a bunch of notes. The customer tells you he needs a gazillion outlets in his strip, and we propose something that's 80 inches long. Well, that's not going to fit, and that's, you know, it's a real problem for you, and, you know, kind of scratches at your credibility. So we want to know what size cabinet the power strips are going to be used in. Is there a particular brand they're interested in? You'll see in a couple slides from now, the breadth of our offering is pretty much, you know, covers the gamut of the manufacturing and the best-in-class partners, and we've got access to all of them. What is the
Hey, Rob, one
density?
point on the sizing issue. This is one definitely to be careful of as clients move into higher amperage on the PDUs and pin and sleeve connectors. Not all cabinets and floor cutouts have really been equipped to handle these larger pin and sleeve connectors. So you definitely need to pay attention to floor cutouts and cabinet cutouts in placing higher amperage PDUs.
That's a great point. I've actually had that happen. Remember when I was talking about the size of those things, some of them are 3, 4, or even more inches in diameter, and if the holes in the top or the bottom of a cabinet to get these things out aren't that large, you're definitely in trouble. And cutting metal in a data center to make the holes bigger is not usually an option. Getting back to the qualifications, and thank you for that, Andrew, the rack densities that they're trying to achieve, both kind of, you know, baseline kind of today, what their requirement is, and if they're going to want to scale, and they have anticipated either technology growth or the quantity of gear they're going to put in a cabinet that may get them in excess of what they're asking for today. You want to know that so that we can help plan. You know, the types of gear they're going to be housing, you know, is it single 1U kind of pizza box servers, understanding if there are blade servers or high-density chassis with high-density storage going into cabinets, because now the power supply requirements, especially for redundancy, some of these blade chassis have 3 power supplies, and they're very, you know, high wattage power supplies that you need to take into account, whereas the rest of the gear in the cabinet may be, you know, more normal, lower amperage stuff, but we've got to take it all into consideration. So understanding what they're going to provide, and oftentimes if they can give us a list of manufacturers, make and model number, and a quantity, we can figure the rest out for them. We can size the power strip based on the types of gear and quantity that they tell us they want to house. The questions about if you want to monitor your cabinet, your power strips in the cabinet, are they doing it today? Is there a particular brand, again, that they like to use or prefer to use? Where's the equipment going to reside? Is it inside a data center? Is it in a colo? Is it in an industrial environment? All of these things, will remote power management are going to be used. If they say yes, you know, we're not quoting just a metered power strip. We're going to have to be at least smart or maybe even switched. And more importantly, or of equal importance, and this goes across kind of everything that we do, is how do they source this type of equipment? Because if it's a new customer prospect that you have and you're trying to become their trusted advisor, and they want to give you a shot, if you don't know how they're going to procure, some people can approve a purchase and approve the technology and the product, and those are the great ones to have, right? You're working with the decision maker. Sometimes You have a guy who can recommend internally, vet it all out, maybe evaluate a product, approve it for his use, and then he turns it over to a procurement arm inside his own business whose sole job is to find that product as economically feasible as possible, which means you're going to get shopped. So without knowing how they go about their procurement process, and again, this is foundational across the board, we can stumble out of the gate and kind of do all this work to create the spec and get them exactly what they're looking for, and then you just gave them their shopping list. So we really need to kind of understand that, and quite often that last bullet there is more so overlooked. So that's just a little editorial from me. What we need to know in here, technically and spec-wise, in order to assist you, is what's here on this screen. So, you know, AC or DC current, more than 9 times out of 10, it's AC. What level of functionality is required? Is it the basic metered smart switched or the outlet level? Do you require software management? We didn't get into that a whole lot, but most of the manufacturers we represent have a front-end software tool that allows you to manage entire deployed fleets of always network attached power strips, and then they can give monthly trending and historical analysis and consumption over time and those types of things that, you know, if they're sensitive to environmentals and have a sustainability kind of focus, they'd like to know kind of what's being used when and when the consumption's up and down. So the software management tools that are out there, they're usually manufacturer specific, but they're used to control and manage entire fleets of network attached power strips. Do you have a requirement for environmental monitoring? Remember, the little phone jacks on the power strips is where you're going to be plugging temperature sensors in, and that's usually local to the cabinet that the power strips are in. Most of the power strip providers give you 2, the ability to plug in 2 temperature sensors. What's the form factor down on the right-hand column here? So what are we looking at? Vertical, you know, 0U or the horizontal. And now we get into the nitty-gritty. The types of outlets and how many. It's important to know that. Again, the voltage, the current, the phase, all of those things we can't figure out for your customer unless we understand about the application and what they're providing to us. So you've got to kind of go through all of these things with your client. Otherwise, you're going to be asking them a couple different times for the rest of the information. This chart is provided to us by one of our partners, Server Technology. So you'll see some kind of branding things here. This POPS, that's their outlet level control. It stands for per outlet power sensing. But this flow chart here kind of synthesizes down those previous 2 slides and can be used to across all of our manufacturers. These kind of questions. Do you need current displays? So if the answer is no, a basic power strip is what you want to hone in on. You know, if the answer is yes, then let's ask if they want a network connection for network monitoring. If they don't need a network connection, we're going to quote a metered option. If they do need a network connection, now we got a couple more questions. Do you want outlet level control? Do you need power outlet level monitoring? So you move from left to right and top to bottom here, and it kind of sets you up in the class of the type of product that we'd like to propose. So again, I put this Server Tech kind of flow chart up there. I think it's a really good tool and can be applied kind of manufacturer's agnostic for your use. I can send that out as well as a PDF. Kind of wrapping up a little bit, I talk about the flagship kind of best-in-class partner offering that we have. The one that's kind of missing here is Eaton, and we do have access to Eaton. I'm not as familiar with kind of our program with them or where we stack rank in their hierarchy from a pricing and discount structure, but I do know that we can acquire the Eaton product through their master distributor, a company called HM Crag. But, you know, APC, this is in alphabetical order, APC, Geist, Packet Power, and that they're more of a niche technology because they include some wireless monitoring capabilities in with their basically smart power cords versus a power strip. And so we would do something separate to kind of show you their product. But APC, Geist, Raritan, Servertech, and Vertiv. And Vertiv's the new brand that used to be Emerson Network Power or Liebert. And not too long ago, Server Technology was also acquired by this behemoth, Legrand, who also owns Raritan. So it will be interesting to see how these organizations come together, if they will, how they'll be managed, how the sales teams will be structured, et cetera. And to see just how Legrand kind of rolls them out as time goes on. But if you add Eaton into this, we do have almost the whole kind of gamut covered, from a preference to a manufacturer, and certainly from all the types of form factors, styles, and functionality that are available. So I think that wraps it for me. Again, there's some technical stuff that may have been foreign to you. Power strip qualifications, unfortunately, it's not just 2 or 3 questions. You saw a number of different bullet points. That's all important. I do have some supplemental information I will make available, like the charts of the outlet types and those sorts of things, and that kind of flow chart that I showed at the end as handy tools. But the team inside, my engineering team, Jen on Kurt's operation team, we're able to turn around the proposals to help get these configured for you, to engage with your customers on consultative discussions around power and kind of methodologies that are available. And again, when you're calling on customers, when you're visiting them, you won't get a sense of any of this unless your customer is really savvy and tells you about it, until you get a tour of their site and can walk to the back of a cabinet and just see how they're providing power. And sometimes what you see just scares the crap out of you. I've seen hospitals that plug one power strip into another power strip, and from cabinet to cabinet, and they got one
you forgot the extension cord.
PDU. It's crazy, yeah, and you don't get a sense of that at all if you're meeting your customer in your office, in his or her office, or across the lunch table. You want to get in their data center and you want to see things, because like I said, and even if you drag us along to support you, we're going to find something to come back to them with that may be very different than why we were there in the first place. But the tours and the eyes, the visibility, either on the slab or on the raised floor, you can't overcome that sometimes without being there. So I really stress the importance of being able to do that. Comments,
Thanks,
questions?
Rob. I'm gonna stop the recording now. Awesome job.